Hello everyone. So this talk is going to be about client-side development, web development, isomorphic functional client-side web development without JavaScript with Scala.js. So if any of you want to follow along on your laptops, on your phones, the slides are online at tinyurl.com/Scala.js. But they are also here on screen, so feel free to not follow along. So who am I? So my name is Howie. I used to write CoffeeScript at Dropbox, and right now I'm working on the server platform team. And I'm an early contributor and user to the Scala.js project. So I'm not the original author, and I'm not the main person driving it, but I'm someone who's done a bunch of things with it and knows what it is and gives talks about it. So that's my Twitter handle, and that's my GitHub. So here's what we'll talk about today in brief, and let's get started. So to begin with, I'll talk a bit about where JavaScript is going. So what are the trends in the ecosystem today, and why are they relevant? So a few things are relatively widespread. For example, people are more used to doing immutable data structures or immutability, both in JavaScript-land using immutable.js and in, for example, ClojureScript or Elm or other like compiled to JavaScript languages. And there are benefits. For example, if things are immutable, it means that having an undo operation in your website simply means keeping the old versions of things and putting them back into place when it's time. And it also means that you don't need to defensively copy things to avoid people making like accidental mutations to your internal data structure, and makes debugging easier because there's fewer things to worry about. Things are getting more functional. Functional meaning like you instead of mutating some DOM element like you did in jQuery world, you return what you want. You return the result that you want to show people like you do in React. Even when it's tricky to return something, for example, that something is asynchronous, you can return a promise. Or even when it requires crazy hacks, like I want to return the whole web page and still make it be efficient, you do things like the virtual DOM and have the crazy hacks be limited to the virtual DOM diffing algorithm, while in your code, when you're writing React.js code, you just return a whole new page and let React sort it out and make it fast for you. Things are getting more type safe or type checked. You catch bugs earlier that way. Instead of catching it in development, you catch it before you even run your code because, for example, TypeScript will find the places where your code is obviously incorrect and you don't even need to run it. It also provides some other things like documentation doesn't fall out of sync, and it makes bad things look bad. So if you annotate the type as any, and someone doing code review sees this type and sees this any, he'll be asking you, why is this any? Why is it not an integer or a string or a list of user objects? Why does it really have to be any? And it kind of forces you to really think about what you really are putting in your variables versus in plain JavaScript, where you can just put anything there and no one really notices that you're mixing up your variable contents. Things are getting compiled, even in JavaScript world. It's no longer a just reload the browser and refresh the page system. Everyone uses build tools, and people aren't using build tools because they want to make life hard for themselves. People are using build tools because they provide real value. Things like minification, things like dependency resolution, things like other static assets like CSS being compiled and packaged together with your JavaScript. Whether you're using, and they even provide things like new languages like ES6 or TypeScript or JSX. And lastly, things are getting more isomorphic. So, or some people call it universal. But the basic meaning is you run the same code client and server, and you don't need to worry about repeating yourself and re-implementing the same code twice because that's a pain in the neck. Because if you're writing JavaScript on client, writing JavaScript on server, your application lives in the middle, and you can run whatever you want, wherever you want. So that's where JavaScript is going in short, or at least that's where I see it going. So this is what JavaScript looks like today, or maybe last year. I instantiate a new XML HTTP request. I open it with a URL to get maybe the list of repositories I have on GitHub. And I set the onload to set the document body and click send. This is what JavaScript will be next year, or maybe this year if you're using Babel to, or if you're only supporting the latest version of Chrome and Firefox. You have let bindings, which are immutable, and don't do the weird variable hoisting thing that JavaScript tends to do with vars. And you have arrow functions to make setting callbacks easier. Scala.js is a different language that compiles to JavaScript, and traditionally Scala has run on the JVM. But when you look at the Scala code that compiles to the equivalent JavaScript, it's almost the same. So instead of let, they call it val. That's basically not important. You need to put type annotations on things because in Scala world, people tend to use types. It's kind of like TypeScript. And in Scala world, double equals does the right thing, so you don't need to worry about triple equals. So if Scala looks so much like JavaScript, but is actually a whole new language, then why should you care about using Scala in the web browser? Like, isn't this all just a waste of time changing variables, changing keywords around? So Scala.js or the Scala language that Scala.js is based on, has a lot of the same properties that JavaScript is going towards. It's immutable, it's functional, it's type checked, it's compiled, and it lets you write isomorphic code that runs on both client and server. So just some quick numbers. The turnaround time for compiling Scala.js code and running in the browser is about 1 or 2 seconds when warm, so it's not a huge compile time. The applications start at 70 kilobytes, which is massive for a hello world, so that's definitely not ideal. But as it grows, it tends to go to like hundreds of kilobytes for even a relatively large application. So it's not tiny, but it's not too terrible. And the code is very efficient, and in terms of computational performance on the CPU, runs about 1x to 2x as slow as normal JavaScript. So ES6 versus Scala looks almost the same. Why should you care? One thing that's nice about Scala is that it's type checked by default. So for example, in ES6 or ES5 code, if you're writing JavaScript, you make a mistake, you misspell children instead of children. You get a runtime error in the browser, gives you a stack trace maybe, or maybe just tells you a line in the HTML file it blew up at, and you have to go figure out why was it undefined, why doesn't it have a length attribute. In Scala.js code, it looks almost the same, except that when you make a mistake, it gets caught in the editor for you. You don't even need to look at the browser to see that your error that end error has occurred. And because there's a compiler that checks it for you that does the same thing as editor, there's no chance that you'll accidentally check in code that makes such a trivial mistake. This doesn't catch subtle mistakes, but at least it catches the trivial mistakes, so you as a programmer can focus more of your brain power on the more important subtle issues that your program will face. Another thing that Scala.js does very well is that it provides really good editor support. So if any of you have used Java before or C# using Visual Studio, like it's well known that being able to press dot and see a total list of everything your object can do, every method, every variable, every property is very useful. And in Scala.js, rather than sifting through the Mozilla developer network, like line by line, using Command F to try and find the method you want to call, you can press dot, start typing, and see a list of things that you can do on a particular variable, and easily pull up documentation, not just an English description of what the variable does, but a formal type signature of saying that child nodes here returns a node list. It doesn't return one node or a couple of nodes or an array of nodes, it returns a node list object. And append child takes a new child, which is the node, and not anything else. And this is very handy to have right in the editor. You don't have the context switch and flip over to a browser and flip back when you've read something. So let's do a live demo. I will take this application, which exists on GitHub at github.com/Howie Workbench example app, and I'll show you what it's like working with Scala.js. So here we have it. Here is if I go to localhost 12345, here's a small Scala.js example application. If you look at the project, it basically has a source folder, 2 HTML files, one of which is a dev version which you're going to be using for the demo, one of which is optimized version, and as a small amount of Scala code, which is here. Can you guys at the back see the code? Cannot see the code. Okay, I'll make it bigger. Now? Turn off the lights. Can somebody turn off the lights? I don't know how to turn off the lights. Don't know. If no one's going to turn off the lights, then I probably don't know how to turn off the lights myself. Well, I'll just keep going there in that case. So over here, we have what is a small Scala.js application. We have a main method. So this is kind of a holdover from Java days, because Scala normally runs on JVM. And the main method, instead of taking an array of strings like a Java or C main method does, takes in a HTML canvas object. You can see the HTML canvas object. It actually is well defined with a nice signature and everything, with a list of methods and attributes it has. And it gets a canvas rendering context, canvas rendering context 2D, not any other rendering context. And it does some math, uses a set interval in order to draw this cute little serpentine triangle. So that's kind of neat. You can change the color, for example, from black to white, and it'll recompile for you. The first recompile is often pretty slow. Looks like it's not done yet. But after a few recompiles, it tends to warm up and become relatively speedy. So first slow, second not so slow, and after that it gets down to 1 or 2 seconds per recompile. So this is Scala code that draws on a canvas. I'm going to change it for you to show you how to use Scala code that renders to HTML, because that's maybe what most of you are interested in. So I'm going to delete all the code because I don't need it anymore. I'm going to delete this. And I'm going to say dom.document.innerH.body.innerHTML equals hello world. Then we'll run this, and you'll see it's hello world. It doesn't look very pretty, but we'll fix that. So inner HTML is just a normal JavaScript API. It's a bit hard to see the documentation, but it's basically cribbed from the Mozilla Developer Network documentation. So let's do something. I'm going to make a search box to look for people's repositories on GitHub. So for those of you who don't know, GitHub has multiple nice REST APIs, including one for users, which lets you see what repos they have. Rate limit exceeded. OK, that's unfortunate. Authenticated repos at higher rate. Let's try changing that and using a different API. I'm going to use OpenWeatherMap and see if I can make that API work. Actually, I'm just going to skip the API for now, and I'm going to just go for a local search box in the application. So let's say I have a list of things I want to search for. For example, val repos equals a sequence of, I'm just going to give the name of the repos here. For example, maybe I have underscore, maybe I have Scala.js, maybe I have Scala test, and maybe I have a bunch of other libraries that I'm going to write out. I don't think there actually are apple, banana, and mango repos, but let's pretend for now. So if I wanted to show this, I could print out the repos. And it's a bit hard to see, but it turns out at the bottom in your console log. So let's do more things. Let's make a search bar. So first, I'm going to generate some HTML. There's a HTML generation library called Scala tags that's quite popular in Scala.js land. And it lets you generate HTML kind of like how React generates HTML using like inline function calls or inline syntax within your main code base. So for example, I could say dom.document.body.innerHTML is equal to empty. And I'm going to say append child. I'm going to make a div .render. I'm going to do h1 hello world. And I'm going to do a paragraph of today is Wednesday. Okay, so that's basic hello of how to generate HTML. It looks kind of ugly, so I'm going to go get some Bootstrap to make it look pretty, because that's how you make websites look good, apparently. So Bootstrap, I'm going back to the HTML file, which kind of houses this application. Do that, refresh the page, and now it's bootstrappy and web scale. So let's make a search box. For a search box, you need an input. Now we have input which doesn't do anything. And let's say that, well, I want to make the input do something. So first thing I'm going to do is I'm going to take the input out and give it a name. And once the input is out, my input. I can say, well, my input dot on key up equals arrow function. And I'm going to say, well, I guess I need output too, so I'm going to call it my output. Val my output equals an unordered list. So I'm going to clear my output, and I'm going to say my output dot append child. For now, let's just say hello world. Or let's not say hello world. Let's just make it echo my input. So my input dot value. That's what I want. And I think a new call.render. Okay, so reload. Hello world, I am a cow. So that seems to work. Let me make that bigger for you. So that's a basic hello world input output. Let's make it do a simple search. So I want to display things from this repo sequence which match the prefix, let's say. So for repo in repos, I'm going to say if repo dot, or let's say if my input dot value dot, no, let's do if repo dot starts with my input dot value. I'm going to append the, I want to append the repo to the output, not the input. So here we are. And if I say, for example, mangosteen, mango, Scala, T. So that's a simple search box. I could color it, let's say. So let's say I want to val prefix suffix is equal to my repo.split at my input.value.length. I'm going to just wrap this to the next line so you can see what's happening. And I'm going to say span background color yellow. So this list item is going to have a few elements. It's going to have a span whose background color is yellow and has a prefix, and it's going to have a normal suffix. So reload the page, and now we have mangosteen, Scala, test, and all those things as a search box. So this is what Scala.js feels like to use. Like, there's a small compile cycle, which is, I guess, not unlike JavaScript nowadays, perhaps slightly slower. You get very good autocomplete in the browser. You can say like dot and get a whole list of things to do, whole list of things you can do without needing to dig through documentation, because the documentation all just gets pulled up right in front of you. If you make a typo, it gets called out both in the browser, in the console, as well as in the editor without you having actually running the code. And it's a bit hard to see for you guys at the back, but it says, value inner HTML with one N is not a member of Scala.js.dom.html element, which is quite a bit nicer error message than nothing, which is what would happen if you do this in JavaScript, because you'd actually just monkey patch the body element with a wrongly named attribute. And so that's part of the, part of the nice thing. That's what it's like working with Scala.js. So it's immutable and functional by default. So for example, if you try to reset repos equals an empty sequence, this won't compile because I set repos to be a val. If I want to make it a variable, I need to explicitly turn it into a var variable. But by default, things are immutable and functional. Things are type checked, which is really nice, including third-party APIs like the DOM or AngularJS or React. If you misspell the attributes or the methods in Scala.js, you get the editor error as well as the compiler error. And you get very good editor support, such that when you're working with Scala.js, you don't really need to browse the Mozilla Developer Network much. So I can see that, for example, my input has a value, but my output does not have a value. And if I try to leave a value there, it will give me a compile error. Because Scala.js knows that, hey, my input is a HTML.input, for those of you who can't see this, and my output is a HTML.unordered list, and the unordered list does not have a value attribute, and I don't need to tell it, it already knows. So there are a few more things I'll talk about later. So isomorphic Scala.js, that's what the title of the talk was about initially. So one of the big pluses of JavaScript and Node.js was that you can reuse code between client and server. And that's great because everyone hates having to write like a Python algorithm to do some task, and some project manager tells you, oh, we need this to be more responsive, please rewrite the whole thing in JavaScript. And you go and rewrite the algorithm line by line in JavaScript, taking care of the differences in numeric behavior between Python divide and JavaScript divide. And you're doing that over and over for all the different things that you need to re-implement. The other alternative is you make the JavaScript make lots of endless API calls to the server just because you don't want to re-implement code. And both of those are pretty poor solutions. One is annoying and one is really slow. And with isomorphic Node.js, you can write the code once and just deploy the same code to both client and server, and it works great. And most other compiled to JavaScript languages do not have this property. For example, you can't run Elm on the server easily. And most other server-side languages can't be run on the client. But with Scala.js, it also has the same property as Node.js, where you can run Scala on both the server and the client without having to rewrite your code. And I'll show you that now. So I'm going to use the same repo, and the same repo has a different branch called AutoWire, and the name of that branch is, I guess we don't need to worry about that for now. So I'm going to git reset, throw away all the work I just showed you, and I'm going to check out AutoWire. I'm going to kick off the server. So this is SBT, which is a Scala build tool. It's just another build tool, not really any better or worse than any other build tool, but it's the one that we use. So let's give it a sec to compile. And while it's compiling, I'm going to give you guys a short tour of the code base. So a Scala.js cross-compile program looks like you have a folder with a JavaScript folder with all the JS code in it, or Scala.js code in it. You have a JVM folder with all the server-side code in it, because typically Scala has always run on the JVM. It's only in the last 2 years or so it's been able to run on JavaScript. And we have a shared folder which contains any code you want to share between them. In this case, it's maybe just a trait, which is a Scala name for interface, like a Java interface. If we look at the Scala.js code, it looks not too dissimilar to what we saw earlier. We have a bit of wrapper boilerplate from Scala. We get the input box and output box, and we do those. We put the update into a helper function, so we can call it once it initialized and call it again and again. And we have the same kind of document.body.append-child and rendering a Scala HTML template. And if we look at the actual server now, looks like that. And this is just a small demo to show that, yes, I am running this I'm actually talking to a server. I'm not cheating, because this file system stuff only really exists on the server, and a browser can't access the file system like that. So on the server side, it's a relatively bog standard Scala web server. The syntax is probably unfamiliar to you, but most web server routing syntaxes are when you first see them. So this says start a server on port 0000, IP 0000, port 8080. For any GET request, which has a single slash, complete it with a text HTML with this variable, which is a HTML template. For any other GET request, get it from the resource directory. For any POST requests, which are to the path API followed by some segments, do some more work to make the API call work. And over here we have the HTML template. So while earlier on in the client-only example, I showed you a static HTML file, here we're actually dynamically generating HTML on the server. One thing that you may notice is that the server-side, the client-side HTML generation like this, and the server-side HTML generation like this is actually using the same library. So they're both called Scala tags, and it's the same library called Scala tags, and it gets cross-compiled to work on both client and server. In this case, the library is generating a HTML string that starts off the first web page, and over here we're using the same library to generate the div that is this file browser box, as well as the unordered list and the list items that form the body of this search bar. So what is also so I can try changing this. For example, if I say file browser and make it more exciting, it takes a moment to compile. Again, this is the first cold compile. Compile and optimize, and now it's more excited. What's more interesting than that is the fact that we have this AJAX call here, which is made using an API client. So this syntax is going to be a bit foreign to you, but it basically says using the client, talk to this API, call the list method with this argument, and then call it, and for it, this block here, this expression returns a promise, or in Scala they call them futures, and for each, which is the same as like onComplete, take the resulting paths and do things to it. So that looks maybe a bit funny, but I guess it's not too unusual. What's unusual about it is the fact that if I pass in the wrong number of arguments to the API call, it does not compile. And you get the compile error there, and you get the editor error up there telling that, hey, you're using the API call wrongly. So that's kind of neat, because in most like large JavaScript code bases, at work we use CoffeeScript and Python, which is, I guess, the same. When you're trying to use API calls, you're often like looking back and forth between the source code of the API endpoint and the source code of the API call site, and trying to make sure that the URLs match up with the routing, and trying to make sure the number of arguments match up, and trying to make sure the types of the arguments match up, making sure you don't send the JSON dictionary when it's expecting a JSON array, making sure you don't send 3 arguments when it's expecting 2 arguments. And when you're changing an API call is often a very tedious process, because when you make a mistake, you get errors at runtime, and if you don't have Selenium tests to cover your full stack integration, you get errors in production, both of which are terrible. But with Scala.js, the web server, the API call is simply, the client server API is simply defined as a Scala interface. The application, the client server interface is the interface, like who would have guessed? And the server on this side extends the interface like any Java object extending interface would, and you define a method that has to have the same signature as the interface you're extending, and has to have the same signature that your client on the client side is calling. So there is literally no way you can get a fall for trying to change these API endpoints, which is kind of neat. What's more, if you look at the network panel, let's say I go look at target and look at the list calls. Over here, I'm sending up like I'm sending up the path, which is target, and I'm getting back a JSON array of like paths, if you can see in the browser console. If I change it and it's making an endpoint, making a request to the list endpoint, if I want to change the name of the endpoint, I can simply ask the editor to say like, well, it's no longer called list, it's going to be called Moo Cow, because that's what my PM told me, and PMs are always right. So now that my PM has told me to rename it Moo Cow, I simply ask the editor to rename it Moo Cow. It automatically renames the API definition Moo Cow. It renames the API implementation Moo Cow, and now if I refresh the page, I'm now making AJAX calls to the Moo Cow endpoint. And it's like totally seamless. It's simple enough that there's no step which it can go wrong in the middle. The next thing that's interesting is if you want to change how this API endpoint works. So for example, currently I'm sending down a list of the names of the files. Let's say I wanted to send down instead the file size. So I'm going to write some Scala here on the JVM using the Java interfaces to get the file size. So it's okay if you don't follow. So I'm going to map it, and given the file name, I'm going to say, well, it's a lambda, and I want a file name, and I want a new java.io.file. I think I need to say prefix plus slash plus file name dot length. So that's going to be I guess I can say 2 integer, because I think by default it returns a long, and none of my files here are so big. So if we go back to so if I save this and go back to console, you see that it's giving me a compile error saying that you updated the API implementation to return a sequence, if I make this bigger for people at the back to see, to return a sequence of a tuple of strings and integers, but the API definition requires a sequence of strings. So, okay, I guess I'll fix the API definition. I'll make this say sequence of strings and integers. It's a bit of boilerplate to do this, but the boilerplate can't fall out of sync, so it's not that terrible as boilerplate. And now I've updated the API definition. It's saying that, hey, in the client-side code in Scala.js example.scala, I don't know how to take this tuple of string and integer and splice it into my HTML template. Okay, so now I go to HTML template. I do destructuring like some of you may be used to in ES6. So for the tuple of file name and length in paths, I have path, I have file name, maybe a dash, and maybe the italic length. And now, once that's done, and it finishes reloading, once it compiles, I get the file name and the file path in my search box, and at no point in the middle was I able to even run the program when it was in a bad state. So, and if you look at the AJAX calls that are being sent back and forth, you'll see I'm now getting back like an array of two element arrays, which are basically tuples of the results. The last thing that's interesting is that if I want to change it from, say, a tuple, which is like a normal Scala thing, into my own data structure, for example, in Scala you call data structure like classes case classes, so file data. I'm going to call it file data. It's going to have a file name, which is a string, and it's going to have a length, which is an integer. Let's want to convert this to a file data object. So, okay, it's complaining, it expects a tuple, it needs file data. I go and fix that. Oops. So now it's complaining it doesn't know what file data is. And it doesn't know what file data is because we defined file data only on the server, which is here. We did not define it in the shared code. So the shared code does not know what a file data object is. And in this case, the file data is pretty simple. So I'm just going to copy the file data into the shared code and say that among the things we share is the API interface as well as the file data object. So now that works. And it's complaining on the client because over here on the client, it doesn't know how to deal with, over here I'm trying to treat the result as a tuple, but it knows that paths is a sequence of file data objects for those of you who can see this. So I'm forced to fix this and maybe make it work like that. Instead of using this structure, I'm going to use the attributes. And we're back in business, and if you look at the network panel, we're now making request to the mumucow endpoint, and we're getting back file data. We're getting back these like JSON object, a list of JSON objects which contains the file data. And so this is kind of like the, people have always talked about, oh, what if you could share your data structures, what if you could share algorithms between client and server, and we know JS you can, and in Scala.js you also can, but with somewhat a higher degree of safety in that you can't accidentally use something from the browser side on the server side. You can't accidentally use something from the server side from the browser side, and it's pretty explicit in that you have the server code, which lives in this case, JVM folder. You have the browser code, lives in the JS folder. And you have the shared code, which lives in the shared folder. And both sides can use the shared code, but both sides can't use each other. So you don't have this worry about, oh, what if I use the wrong thing and it blows up at runtime accidentally. Furthermore, if I look at the HTML templating logic, you'll notice it's somewhat different, subtly different. So if I say input box dot value here, maybe I want to print it. Start, stop. Now it says value. It starts off empty, which is what you expect. But this works because I can get the value from an HTML input, which I'm rendering on the client. If I say val my input equals input.render on the server, and I say my input.value, I get a compile error. And why is that? The answer is, if you look at what my input is on the server, it is not a HTML.input. It is a string because, at least in this case, the way we set it up for the isomorphic code, for this isomorphic HTML templating library, on the client side, you're rendering live HTML DOM element objects. Each one's an object with attributes and methods you can call and all that. And on the server side, you're rendering pure strings. And it's very easy to mix up where your templates are and what template you're using for what and what you are allowed to use and not allowed to use. But with Scala.js, because you have the compiler to help you and the types to guide you, we know that if I'm calling .value on the input on the server, it's going to be wrong. And I don't need to think about it. It will put it in my face and not let me make progress until I fix it. Furthermore, one thing that you wouldn't have noticed is that on this Ajax server thing that goes from client to server and does the nice type safe, statically checked, verified to not have 404s or 400 Ajax calls, we are using this serialization library called micropickle. And micropickle itself is a library that runs on both JVM and on JavaScript and runs on both client and server. In theory, you could use a Node.js server running Scala.js. In practice, most people use a JVM server because that's what Scala has traditionally been used for. And in reality, it doesn't really make a difference because you can run the same code both on Node.js and on the JVM. But we have our HTML templating libraries which are shared. We have our serialization libraries which are shared. We have the Ajax, type-safe Ajax libraries which are shared. And if you want to share your own code, you can easily just chuck in a shared folder and it will be shared from client and server in a completely safe and easily understandable way. So that's for the demo. So hopefully this has kind of drawn out the fact that there's type safety and type checking, and there's more type checking, and I don't think any other framework that I'm aware of actually type checks your AJAX calls the same way Scala.js does. And especially given that those are the most fragile part of many web applications, I think it's especially important. And the editor support is really nice. Being able to auto-rename your AJAX endpoints, getting in-editor's feedback when your AJAX endpoints are malformed, AJAX call sites are malformed, that's really cool. And the isomorphic universality of it, depending which adjective you want to use, is also really cool and arguably done slightly better than even Node.js does it, because over here, we can verify that you're not putting the wrong thing in the wrong place when you're running the same code in totally different environments. So last things I haven't talked about are ecosystem and production readiness. In terms of ecosystem, it's actually relatively broad. So one common complaint of these compiled JavaScript languages, or even most startup languages to begin with, is you don't have an ecosystem. Why should I use your thing? I don't have libraries, I don't have tools, I don't have people to ask questions on. And in Scala.js, it's quite interesting because you get both all of the JavaScript libraries available to you, as well as all the Scala libraries available to you. So in the early example, I used a DOM, which is like the project lives on GitHub here, but you also have the Scala.js jQuery facade, you have the Scala.js React facade. All of these give you the same kind of easy access to these third-party libraries in a completely type-safe way. And it's really straightforward. In fact, if you look at the way I'm using the DOM in this example, like this looks just like JavaScript, except it's safer, and if you screw up, it tells you. But otherwise, there's no like annoying interrupt to try and define a port or define an extern to make it do the right thing. You just call the function, and it's the same, but if you get it wrong, it'll tell you. So there are a whole lot of these JavaScript libraries which we have facaded, and the ones which haven't been facaded can be facaded relatively straightforward in like an hour or two, basically by reading documentation and transcribing down exactly what is the correct things that it returns. But in addition, you also have all the isomorphic Scala libraries. So I showed you Scala tags, which is a HTML templating library that renders strings on the server and DOM elements on the client. MicroPickle is a shared serialization library. You have things like Scala Z or Scala Async, which is like ES7 async await, but available today. ES7 async await is also available today, also under cross-compiler. So in a way, it's very similar. And a whole bunch more libraries that all work on both Scala.js and Scala.jvm isomorphically. And many of these libraries need about 2 lines of configuration to cross-compile, so it's really compatible. In terms of production readiness, there are a few cute demos. So here is a ray tracer I wrote in Scala.js. It's really pretty, like 200 lines of Scala code. It's not really complicated. It does all the vector math, physics, reflection, refraction thing, and prints a nice picture. Here's a cute 2D platformer game I wrote, which this uses hand.js to polyfill the mouse inputs or keyboard inputs, as well as, mouse or touch inputs, as well as Chipmunk.js to handle the physics. And this is a game that's basically like 3,000 lines of Scala and reasonably complex and multiple stages and all that. And it kind of shows that you can do relatively high performance, not that high performance in this case, but relatively high performance interactive things using Scala.js. Last demo is, well, I showed some of you earlier, is a to-do MVC because everyone needs to-do lists. It works. There's not much else to say about it. And there are people out there who are using it in production for various purposes, some of which are betting projects or startups on it, and most of them seem pretty happy with it. There are some teething problems, but generally they get fixed pretty quickly. I don't know of any huge companies which are using it, so it's not like Google Dart, which has like 1 million people behind it. But there's a good community behind it, and the Gitter channel has something like 600 to 700 people at any time. So why Scala.js? Because it's like JavaScript, but in many ways it's better in the ways that JavaScript is already going. It's immutable and functional by default rather than by having third-party libraries. It's type-checked by default, and far more than even TypeScript gives you. The editor support is amazing. Like having the drop-down of every method can call on any DOM element is really cool. And having it be actually accurate rather than just be some regex thing that's threw together using C tags is even cooler. It's isomorphic and universal, just like Node.js, but better. The ecosystem is broad, and it's pretty much ready for real usage. So that's Scala.js. If any of you want to learn more about it, we have a website, which is like kind of pretty, like most websites are. and I'll take questions. Cool. So this is not Scala.js specific. So IntelliJ does not know this is Scala.js. As far as IntelliJ is concerned, this is just Scala. And any editor which supports Scala will do this, including IntelliJ, Eclipse, and with the Ensign project, Vim, Sublime, and Emacs. So those are all the standard Scala editors, nothing to do with Scala.js. It's just that Scala lets you do this when you specify the types of things. Cool. Next question. I sent out benchmarks at one point based on the test suites of my isomorphic libraries. And if I remember correctly, Scala and JVM is about 5 times faster than Scala running in Chrome, which is about the same speed as JavaScript running in Chrome. So JVM is still faster, but you can't ship the JVM everywhere. Yes. That has already happened. There is an ES6 mode which compiles to using arrow functions and FUNCTCIONs instead of function keywords, and they use other things like lets and consts. And there's also a compiler flag that flips over to strong mode, which is like the thing that Google is trying to push to make JavaScript faster by trying to reduce its dynamism a bit. Both of those aren't really useful. I guess it reduces the code size slightly, but not by a huge amount, especially after gzip. And in practice, no one actually looks at a generated JavaScript, so no one really cares what it looks like, especially because you have source maps. So when you get error messages, it shows you the Scala line numbers rather than JavaScript line numbers. But if you do look at generated JavaScript, it's really ugly. So it's like that. It's a lot of generated JavaScript for the standard library. But it gets optimized until it's pretty fast, and you generally don't need to care about how much it is. Fast and small. Over there? I would say the major benefits are, one is types. So that's a matter of taste. Not everyone likes types. If you are the type, who likes types, then you would like Scala.js more than ClojureScript, because ClojureScript doesn't have types, and type closure is a half-alive experiment. Second reason is editor support. ClojureScript does not have as good editor support as Scala.js does. Clojure does not have as good editor support as Scala does, even with things like the new cursive Clojure IntelliJ editor, which is, I've heard, really good. You do not get the 100% correct autocomplete that you do in Scala. Most other things come down to types or editor support, to be honest. So things like ease of refactoring comes down to because you have types. Things like ease of better navigation in the editor comes down to types. And some people hate lisps. So if you're one of those people who hates parentheses, you won't use ClojureScript. But yeah, I don't have a real strong feeling about that. There's a multi-phase compilation pipeline. The first phase uses its custom tool, which results in this. The second phase uses Google Clojure, which then crunches it down into one huge unreadable blob, and that's when it becomes 70 kilobytes. This one's about 1 megabyte, but Google Clojure makes it really small after that. Yeah. Any other questions? I guess we are done. Thank you.